Bismillahirrahmanirrahim. Assalamu alaikum. Today's topic is related to electrical measurement and instrumentation lab. Today we will discuss experiment number 5 of the lab manual to assemble the capacitive AC bridges of electrical measurement systems using discrete components. First of all, we will have a look on the description of the AC bridges. The AC bridges uses for measuring the value of the unknown resistance, inductance and capacitance. The AC bridges are very convenient and give the accurate result of the measurement. To measure the value of the unknown resistance and capacitance of the shearing bridge in electrical measurement systems using discrete components. In this experiment, we will just perform shearing bridge part, which is 5A. Next, we move towards the introduction about the apparatus. As this experiment is totally based upon the discrete components, so we will have only discrete components consisting of resistor, capacitor, AC voltage source, detector, that is an ammeter, and NI Elvis board 2, and of course the NI Elvis instrument launcher software. The construction of bridge is very simple. The bridge has 4 arms, one AC supply source and the balance detector, which is our ammeter, available on the NI Elvis board. It works on the principle that the balance ratio of the impedances will give the balance condition to the circuit, which is determined by the null detector. These are 2 formulas in order to calculate the unknown resistance and unknown capacitance. In lab task, first of all we will construct the circuit on NI Elvis board. These are the given values of the resistors: R1, C3, C1, R2, Rx and Cx. In these, C1 and R2 are variable capacitor and variable resistor respectively. We want to find the values of Rx and Cx. What we will do is, we will connect this circuit according to the diagram shown in above slide, and we will on our power supply, that is our AC supply. Then what we will do is, we will change the value of resistor R2 and we will change the value of capacitor, that is C1. At one point we will get a zero deflection of galvanometer, or in this particular case we are using ammeter. We want to calculate or measure our current on 0 at point A and point B shown in the circuit diagram. Once we will get the value of current as 0, then at those values of R2 and C1 we will calculate the value of Cx and Rx according to the formulas shown above. Next, we will fill up the readings in this particular table. In first step, we will take the unknown value as 1 microfarad Gradually we will increase the value of unknown capacitor, that is 10 microfarad, 100 microfarad. We can choose these values randomly, and then we will fill out the values corresponding to these unknown capacitances. First we will note down the reading of ratio of arm value R1 over R2. Then we will move towards the variable resistor value that is being obtained from the null detection condition. Next, the variable capacitance value at which we get the null detection, and then we calculate the value of Cx from the formula, and then we calculate the percentage error. Here is the formula for the percentage error: measured value minus actual value divided by actual value multiplied by 100. Measured value, we obtained this value from our measuring device, that is our DMM, available at NI Elvis instrument launcher. The actual value is the value of resistor or particular capacitor which we select from the laboratory, like we say 10 ohms, 10k. These are the actual values. We will implement this circuit. Now this is the circuit implemented on the breadboard. This is the capacitor in series with the resistor. This is capacitor parallel in resistor, and this is the variable resistor, and this is the capacitor in one branch. Now we will measure the output at the oscilloscope. This is our function generator. We have supplied 100 Hz and 5 volt peak to peak. You can see the waveform on the output. Now what we will do is we will vary our resistance with the variable resistor and see the effect of it on the oscilloscope. As you can see, the output waveform is gradually decreasing with the variable resistor, and now you have to take the readings of the resistors at which resistance or bridge is balanced or the null condition is obtained, and from these measurements you can fill up the manual and draw a conclusion. If you have any queries, you can ask in discussion session. Thank you.